Let's get started. If I have any questions, throw them in the chat. But I finally got it posted. I was working on my notification, so I'm sorry. I'm a minute or two late, 2 minutes late. But um, once again, just trying to work out these kinks as I go and getting better as we go too. So today, I want to do some open response that was assigned today. We only might get through the first question and save the other one for Monday, but that's okay. But let's take a look. So we have two graphs, and what I teach is the first rule of graphs. You have to know which graph we're looking at. So when we look at these are two different graphs. One is the original function, one is the derivative. And there's a lot of information that can be pulled from both of these graphs, but different graphs give you different information. If I was looking at my speedometer in my car, do I know how much gas is in it? No, because those are two different gauges, or the temperature, or my battery life. Like, those are all different gauges. So those different gauges give you different information. Same thing happens in calculus. Like, the different graphs definitely give you different information. So for this one, what they want us to do is find the average rate of change. So the average rate of change is f of b minus f of a over b minus a. That is your slope, your average rate of change when you're trying to find the average of something. So when we do this, we're, whoa, thank you for the follow. And that scares me every time. Trent, thank you for the follow, man. I much appreciate it. But definitely scared me. Okay, so looking at this, we want to find the average rate of change. So what are our two ordered pairs? When we look at this, where do we start? We're starting at -1, -2, and then we're starting at 4, or we're ending, 4, 1. So when we look at our two ordered pairs, this is what we'd be looking at. So when we plug it in for our slope, we're going to do, if I consider this A, this would be f of A, and if this is B, this is going to be f of B. So I would have 1 take away -2, and I will have 4 take away -1. So then my slope becomes 3 over 5, because a negative negative makes a positive. 1 plus 2 is 3. 4 plus 1 is 5. So what we are looking for is we are looking for this slope on our instantaneous curve. Now, if we look, we could maybe guess that maybe it's here, maybe it's here. I don't know. But what I do know is I have a derivative graph. How does that help us? Well, what value are we looking for that slope to equal? 3 over 5. Well, where's 3 over 5? Isn't that between 0 and 1? And if, oh no, I hate when this thing starts clicking. I don't click the button, but it starts clicking on its own and then doesn't stop. But think about 3 over 5. Isn't that a fraction? And don't we hit that graph twice? So what they're saying is find the average rate of change. We did that over the interval from -1 to 4. So that's why we started at -1. We went to 4. And then it says for how many x values on the interval from -1 to 4 does the instantaneous rate of change of f equal the average rate of change? I know that's really blurry, but I did the best I could. And if you looked at this question, that's exactly what it says. So where is the instantaneous rate of change equal to the average rate of change? So they're saying, where is this average rate of change from beginning to end the same on our instantaneous rates of change? And remember, those slopes, as we go up the graph, are turning and changing all the time. But if we look at our derivative graph, we can look and see instantly where 3 over 5 gets hit. And it gets hit 2 different times. So 2 times f of prime equals f of b minus f of a over b minus a. Yes, no, maybe so. Hopefully that makes sense. If you have, once again, if you have questions, throw them in any chat, whether you're in the Discord, whether you're in Twitch, anything and everything. All right, well, let's go on to the next one. So part B, write an equation for the line tangent to the graph. Okay, so as soon as I see write an equation for the line tangent, I'm doing this. I'm writing the point slope formula. Then I would actually go as far and probably do this, so that I remember, or I remind myself that the slope is the derivative at whatever value we're looking at. So we need a point. So we need a point and a slope at that point. So when we do this, we have to have the derivative at that point. Okay. So that's what we're going to be looking at. So we need an ordered pair. So we have x equals 1. What does y equal? Well, at 1, we are down here at -2. Okay. Nope. First rule of graphs. Gotta know what graph you're looking at. So when we look at 1, really we should be looking at what value? 2. Careful. That happens all the time. Don't get twisted. I know whether you feel I rushed or something, but I've noticed my mistake. And the reason I noticed my mistake is really kind of my next step. What I'm looking for is the slope of the curve at 1 as well. What is the slope of this? Well, that's 0. So very quickly I could go back to, well, I need the ordered pair x and y, but I also need the derivative. So in order to get that derivative, I got to look at the derivative graph, and I would have went, wait a minute, that's where my y value came from as well. That can't work. So that's where I would have checked myself and would have known that I probably grabbed a wrong number. So now let's plug in our values in. So y minus y1, which is 2. Our dy dx, which when we look at the value or the slope, I'm screwing up again. When we look at an instantaneous rate of change, we're looking for this slope right here. That's what the slope of the tangent at that point is. The slope of this is 0, but that tells us the change in concavity, where this goes from concave down to concave up. So when I look at this, I really need this actual y value of -2. And that's where my derivative comes from. And then x minus x of 1, which is we're looking at when x equals 1. So I could have tried to calculate this tangent or that slope by getting ordered pairs that are really, really close on both sides. Or I could just look at what the y value was at x equals 1, and that's why I pulled -2. That's why I had to change it from 0. 0 is the second derivative. It's the slope of the tangent of the first derivative, and that is actually the second derivative. So if we were to do d2y over dx2, that's what would be 0. Okay? Not exactly what we're trying to calculate here, but this is. Now, once I do this, make sure you solve it, because for some reason, AP Central loves that. And we're left with y equals -2x plus 4. And this would be my final answer. And technically look at how many mistakes I made in this problem. You know, I put the wrong y value in. I put the wrong slope in. But when you start to work through this and you start to understand it, and you can check those mistakes that might have been made, that's when you can really start to be successful at this and understand, do I have the right answer or don't I? And trust in what you're doing. And I know it's a little poor form, but I think when you make mistakes, that's when you learn the most. So understanding that this slope really is the second derivative and not the first derivative, the y value is what the first derivative is at -2, which makes sense because when we look at the slope of this line, it's a negative slope and it's a pretty good one. So, and is the slope of that tangent 0? So would it have made sense that it's 0? No. But does it make sense that it changes from concave down to concave up? That I might be able to get on board with. And so understanding what graphs, I don't get it. Why is this slope -2? Okay. So when we look at this, we're looking at this point right here and the slope of the tangent line. So is that slope going to be 0 there, or is it going to be a negative slope? And if we look at this, we want it to be a negative slope. So that's when we look at this graph and we see what is the y value at x equals 1. And that's when we get the value of -2. And that's why the slope of this line, or the derivative, is -2. Yeah, it's a negative slope, right? Is it a 0 slope? Like if we went back to what I originally thought, is it 0? No, this can't be 0. So it really has to. Now, could it have been 0 here? Yes. Could it have been 0 here? Yes. And look what happens. We cross 0 at both of those places. Okay? So that's where you have to understand the graph and the connection of the graph to the first derivative to the original function. And this will just take time and practice. And really, we're going to kind of hone in this on this last, this unit that we're working on right now. But does that make a little bit more sense? Does that clear it up or no? Awesome. Sweet. Well, if anything else comes to mind, throw it at me by all means. All right. So for each limit, and we're looking at two different limits. Also, remember how this is set up. Isn't this f of x minus f of a over x minus a? And shouldn't that be a bell ringer for that? And then obviously you need the limit as x approaches a. But remember that? How we connected that derivative to that one? So making sure when you look at something you understand we're looking f of x minus f of b minus f of b and x minus b. When we look at that, understanding we're really looking at the derivative. And you might go, yeah, I don't see that yet. But the more practice you do, the more you will get, hopefully, there where you start to see these. And what am I supposed to do with this? I've got graphs, and that's about it. So knowing and trying to understand how to look at these and understand the lingo that is used and making those connections. So find a value or give a reason why it does not exist. So the reason a derivative would not exist, remember, it could come to a cusp, no derivative there, could come to a point, or jump discontinuity, or an asymptote. Whether we can look at that. Yuck, that's a terrible asymptote, but asymptote's another one. So all of these could happen. So first value we want to look at is x equals 2. And if we look at x equals 2, we can see it's right here. But also look right here. And what happens to, see, that's where that clicking and keeps writing type thing. What happens at 2? is there a derivative there? Well, it shows us that the value is 1 for that derivative. So then that means the slope at that point should be 1, correct? So does the derivative exist? Yes. And what's the value? 1. Now, if we were to talk about the second derivative of a, where we're looking at this point on this graph, that does not exist because it comes to a sharp point. Like, is this going to be increasing or is it going to be horizontal? Like, the limits would not equal each other from the left side and the right side. So this is where you would have a problem. But if we look, the limit on this side and the limit on this side, they both approach the same value. And what that value is going to be 1. So, for each limit, find the value or give a reason. So, this one, the limit as x approaches 2, f of x minus f of 2 over x minus 2 equals 1. Okay, and then the next one is at 3, and look what happens at 3. Don't we come to a point? So right there, the limit as x approaches 3, f of x minus f of 3 over x minus 3 does not exist. And that's because it comes to a point and the limit as x approaches 3 from the left equals a positive, and the limit from x approaching 3 from the right equals a negative. So therefore it doesn't exist because you can't have a positive and a negative. And we could actually put 1 and negative 1 in there. So therefore the overall limit doesn't exist. Let's real quick. I just want to look at this. Let's look at what it would have been, what they say. So the f prime at 2 equals 1, which is what we said. And then the limit does not exist. F is not differentiable at x equals 3. So really their justification was just it's not differentiable at x equals 3. I don't see how ours is any different. I don't think it's going to hurt anything. So I'm okay with that. I'm on board with it. All right. Last one. We're bringing in a whole nother function. So let g, so now g be the function defined by g of x. So now we have a g of x function. And g of x, they're saying, is e to the x times f of x. And of course, they want us to take the derivative of x and then plug in 0 when we're all done. So we need to take the derivative. So what you should be seeing is the first rule of, what does the dot stand for? Multiplication. So this is a multiplication. So that means product rule. Man, it does scare me. Dragion, Zelepzis. Welcome, man. Thanks for the follow. Or she. Thank you for the follow. Much appreciated. All right, so product rule. So that means we need to take the first times the derivative of the second. So we're going to do e to the x times the derivative of the second plus the second, which is just a normal function, times the derivative of the first. And e to the x, when we take the derivative, it ends up being e to the x, but really it's e to the x ln of e. And the reason I explain this and I tell my class is 2 to the x. If this was my function, and I want to take the derivative of it, it is like e to the x is e to the x, 2 to the x is 2 to the x. But we're left with this ln of 2 at the end. So what happens, this is definitely something that needs to be memorized for the AP exam right here, is the ln of e just comes out to be a 1. And when you multiply 1 times anything, you get whatever that original anything was. 2 times 1, 2. 5 times 1, 5. E to the x times 1, e to the x. And that's why we end up with, when we say what's the derivative of e to the x, everyone just says e to the x. But it's because you're ingrained with that. But you still need to remember ln of e just turns into a 1. So we are just kind of oneing that out. All right, so g prime of x is e to the x times f prime of x plus f of x times, now we're just going to put e to the x. So let's clean it up a little bit. So first times the derivative of the second, and for the derivative of the second, we just have to put f prime of x. We don't know what it is. It's just our function's derivative, okay? And then we're going to add our original function f of x times the derivative of the first, which is e to the x ln of e, and we simplified it just to e to the x. Now, our last step, remember, what was the overall goal? They wanted g prime at 0. So now we need to start plugging in 0 for our x values. Okay, anything raised to the 0 power, once again, kind of that fundamental knowledge or pre-calculus knowledge that you have to come into class with. But anything raised to the 0 power becomes a 1. I've had this age-long debate. I remember having it very clearly in college. Like, how can you raise something to the 0 power and it come out to be a 1? I get it. But just understand it's one of those rules, and I don't want to go into it because it drives me nuts. Because I was definitely not on board with the kind of the reasoning that keeps being given to me. All right, anyways, I don't want to get caught up on that. So f prime at 0. So once again, let's go to which graph do we need to be looking at? We need to be looking at our f prime graph. If we look at 0, what is the value at 0? Well, we're right here, and I think it is the value of 1, or yeah, positive 1. When we look at this, you can see that the slope is here, so it's a positive slope, and I think 1 is, I mean, I don't think they're going to go too crazy. Like you trying to have to guess what that value was. It should be something very clearly that you can see, and at 0, it should be 1. Now, f at 0, so now we're looking at 0, I would say that that is probably a 3. So when all things considered, we get 1 plus 3, and g of prime at 0 comes out to be 4. And if we take a look, it says 3 plus 1 is 4. So we did kind of come through and get what we needed to get for that. On Monday, I want to work through this one. Put the answer up too much. This is kind of your basic, what they say most times when you're doing this. It's just telling you it's a non-calculator question. Here's your table. This starts to give you some basic information. The number of passengers who boarded a ship is modeled by the differential function p, where t is the number of hours since boarding began, and values of p at t for selected values of t are given in the table above. So we have hours, and then we have passengers at those different hours. According to the model, what is the average rate at which passengers board the ship, passengers per hour, over the interval from 1 to 8 hours? Now, once again, average rate of change. They're telling you to kind of go through that slope idea, but pay attention to where they start and where they stop. Because if we started at 0 and went to 8, that's a different slope than starting at 1 and going to 8. So be cognizant of that. So we should start at 1 and go to 8. Write p prime 4.5 as a limit of a difference quotient. Use the data in the table to approximate P prime at 4.5. Show the computations that led to your answer. So what is going to get us 4.5? Well, we could take the slope from 1 to 3, take the slope from 6 to 8, take the slope from 3 to 6. All three of those hopefully would start to approach what our limit is at that value. So I guess you could just do the 3 to 6. It's got to fall in between there. Use the data in the table. This is where I would do 3 to 6, and then if I got done with everything and I had extra time at the end of the AP test, I might go back and kind of do 1 to 3 and 6 to 8 to show that those limits keep getting closer and closer to the overall. But I'm pretty sure you just need to do 3 to 6 and show what it could possibly potentially be. There must be a time t between 3 and 6 at which p of t equals 500. Justify your answer. So right there, if it's not ringing a bell, IVT, the intermediate value theorem, they give you two numbers and they show you that a y value is in between the 204 and the 600. 500 is in between there. So at some point, if it's continuous, so that's once again something we need to kind of bring into our problem when we're trying to explain this. This is what the IVT does. You must prove that it's continuous, because once we do, at 204, if we count up to 600, at some point we have to cross 500. Okay? And we'll show you how to do that on Monday. And then the total number of gallons water used by the passengers on the ship is modeled by, so now they're giving us a different function, where t is the number of hours since boarding began. Find g prime at 4, the rate at which passengers use water in gallons per hour at time t equals 4. So they'll give you a function. Looks like the function is 120t times the square root of t. Okay. So trying to bring in a little derivative. They're obviously going to throw a product rule at you. And you actually don't even need the product rule if you convert the exponents properly. But once again, just little tips or tricks that you could look at. And go from 0 to 8. If we're looking for g prime at 4, so then we would take the derivative and plug 4 in. And we have a function, so we don't need the table for this at all. The table is something completely different. So this is where, can you take your brain away from that table because you think you might have to use it every time, and for this problem you actually don't. You just take the derivative and plug in your value, which is 4, which is easy to do. And they also want to make sure, because a lot of these times, well, I found 4.5 up here in part B. Do I need to use it in part D? No. You just need to understand what the question's asking and answer it properly. So like I said, we will go through those solutions on Monday to go through this problem. I've got no problem, but I want to give some helpful hints to my calculus students, because I know they got to have that done before Monday. But at least they can have like some help afterwards to see where they might have needed a little extra practice. All right. I'm going to not stop the live feed, but I've got to start working to convert this over to a video. So thank you for joining. I hope you enjoyed. And if you have questions, throw them down in the comments. Also, like and subscribe to my Twitch channel, or become a member. Math Dragon Tutoring. I have a Discord channel. The link is in all of descriptions everywhere. Whether you go to TikTok, whether you go to Instagram, whether you're a Twitter follower, or even in Twitter, or a Twitch follower, all of that, join the community. Once you get here, you have to read through the rules, and if you need help, watch a video. And then once you read through the rules, then you will have to gain a role, whether you're a student or a parent. And then you'll have access to all of this great information. And AP Calc, I keep throwing stuff in here when I do it. I also load things up on my YouTube channel, so feel free to wander over there as well. Especially for that open response limit question that we did a couple weeks ago. Check that out as well. All right. Okay, so I am going to stop the Twitch stream. So anyone watching from Twitch, thanks, Trin, you as well. Anybody watching the Twitch stream will be done, but you're welcome to join back in on Discord and kind of watch how I make a video on YouTube. You're welcome to do that as well. All right, but everyone else, thank you for coming out on Twitch, and if you want, jump in.